There we go. Thank you.
All right, so here's the quick overview of what we are going to talk about right now. Remember in the previous session where I mentioned one of the big issues that a lot of DBAs run into, or that I experienced when working with a lot of DBAs, is they don't have an approach that is consistent and reliable for helping them figure out what's going on with their SQL servers and getting to deeper information about what is happening there. That's what this session is all about. And of course, I'm a tools vendor and I believe in the power of tools. I'd love for you to take a look at our tools because they make this process that I'm about to show you so much less painful. You know, they consolidate, collect, and do all of this work for you. However, having said that, I wouldn't ever suggest that you don't need to know how to do this, because you'll have plenty of servers for which you are responsible, and yet you don't have a monitoring tool or capability built into that system. Or maybe you are a consultant, and so some of them have monitoring tools and some of them don't. And so you have to be able to provide insight for systems that don't have any kind of tooling outside of the native tools. So that's what we're about to do here, is we're going to imagine that we have a SQL Server problem situation. We need to get from the diagnostic, kind of the detection phase. Oh, we've detected that there is a problem. Could be as simple as someone telling us that things are bad. Then diagnosing exactly what the problem is, because so much of the time people make knee-jerk responses, you know, kind of a reflex response to performance issues that leads them entirely down the wrong path. And then from detection, diagnosis, then finally to remediation. And how are we going to fix this particular problem that we're experiencing? Okay. So where should we begin? And this is actually one of the most fundamental questions about the troubleshooting approach. And it's actually also has to do a lot with why I asked Daniel to talk about X events as well, since this session doesn't have any significant amount of content about X events in it. So there's a lot of different places when we start to work with SQL Server on a trouble resolution situation that we can get information. The problem is that much of this information is either A, not actionable, meaning it doesn't produce, it doesn't move us forward to finding exactly what that root cause is, and maybe it opens more questions than answers even at that. And then the second point is that does it actually give us information that we can act upon? So, for example, if we jump the gun and move to one of the more advanced techniques for doing trouble resolution, we may have to come back to an earlier version that if we just, an earlier information source, that if we had just checked quickly, it would have ruled out all sorts of other problems. So now we're wasting a lot of time going back and forth. So the gist of what I put together here is a set of steps that you can follow every time that will very consistently get you to the root cause of a problem on your SQL Server. And then from there, you can start to Google, you know, to see if there's a specific resolution to the problem there that you're experiencing. Another thing I do want to point out, and I've done so throughout the earlier session and now, is the power of our community. So if you get to that root cause analysis phase, you found out what the root cause is, that's a great time to start working on SQL help and get some other investigative oriented people to give you a little bit of a hand. Another URL I want to make sure that you all know about is dba.stackexchange.com, or is it Stack Overflow? Stackexchange.com. So this is a place where there is, you know, it's a question and answer website, and it's very elaborate, and in the sense that you'll see that there are lots of people responding to questions as well as people asking questions. You see maybe there's a half a dozen different answers to a particular problem. Other members of the website can upvote or downvote those responses. And so it usually doesn't take long to find a really good answer for most questions, because most questions, to be honest, have already been asked, at least when it comes to standard sorts of errors. So keep that one in mind as another potential source. Once you get to the problem root cause, to apply a remedy to that problem. So SQL Help on Twitter and dbastackexchange.com. All right, so there's, again, lots of places we can start. Here's my approach. It's a six-part checklist, a six-part methodology, all right? And the first thing, I guess I should say actually here, is that X events can be used pretty much for every step along the way. However, I'm old school, right? I started working with SQL Server back before it was a Windows product because Windows hadn't been released yet. And so what I'm presenting here is primarily not X events. And I should probably go ahead and create a corollary to this that includes all the X events too. But here's our checklist. The first question that I always ask when somebody comes and complains about performance, or I have some alerts go off that hit my desk, my first question is, well, what the heck is different about yesterday than today? You know, we didn't have this problem yesterday. And that comes from some of the battle scars I carry of working in places where, say, all the dev team had SA privileges on the SQL Server. And so you're not sure who's changing what. It could be anything from SQL Server SP configure settings, like Daniel was just showing, or introducing new tables without telling anyone else on the dev team that that was happening. So how do we see if something has changed? The next super important question is the problem inside or outside of SQL Server? And this seems like a fundamental sort of keep it simple, stupid, the KISS principle, one of those just simple principles that everybody would apply to troubleshooting. But I can't tell you how many times I've worked with people who have not done this step. And again, it's a very fast step. It only takes 3 minutes to verify whether it's inside or outside of SQL Server. And if you don't do this, this is one of those steps where you have to come back and check later just to see if this might come into play. Now, we also need to check to see if errors are involved. Again, when I mentioned that concept of a knee-jerk response, kind of this reflexive response to a problem, I see that a lot, particularly for DBAs who work closely with dev teams, and they're so used to dev teams introducing some new code that actually make things worse, that they're like, okay, what did you guys do now? What's the bad code at this point? And they haven't gone to see if there's any troubleshooting, red flags waving. They just assume, well, I'm always dealing with performance regressions because of new code the dev team's rolling out. And so they get bit by this by not checking the error logs. Weight stats. So I'm going to show you a little bit about weight stats. Then we're going to look at weight stats and correlation of weight stats against other metrics. And then finally, if you're doing your methodology right, you don't just stop when you've resolved a problem. You actually have what some people call a post-mortem, or you have a follow-up process, okay? So we'll talk about that as well. So let's talk about step one. I referenced this earlier. Change equals risk for a DBA. And so if you're able to check this first before you go on, then you're going to be in great shape. The only problem is that keeping track of what sysconfigures has set up for the instance of SQL Server, or what the database options are and the database metadata is. Only problem is that you have to have done some initial work, at least according to my methodology. Weight stats actually do make this a lot easier. But let me show you what I'm talking about. Okay, so I'm going to pull up. All right, I'm going to pull up Management Studio. And so what I did back in the old days was I created a SQL query. And what this does is this SQL query takes a hash of all the option settings in the sys.configurations table, the system table, right? And so I run that one time, capture that value for that particular instance of SQL Server, and then I create a SQL agent monitoring job. Remember, SQL agent has that alerting, and I run this query again every morning to compare it to the previous value. And what happens is, because I've got a hash of all of the different server settings, this value right here, if anyone changes any of the values of the SP configure settings, this hash will change. And so I know in an instant whether someone has come around and tinkered with any of the SP configure settings. An example of one that I used to have to deal with quite a lot was, again, we're talking late 90s, early 2000s. Uh, a lot of the extra components that come with SQL Server, you don't always need, right? So if you're using SQL Server analysis services, I'm sorry, if you are installing SQL Server and you just install everything, but you're not using SQL Server analysis services, that's actually a waste of resources to install it. But there are some times when you are using SQL Server analysis services on the same instance as SQL Server. And because of the way SQL Server, particularly in those days, did memory management, it was very brittle and it might break and cause you lots of different problems. So what we would do if we had a SQL Server that had both SQL Server and analysis services is we would figure out how much RAM analysis services actually needed, and we would reduce SQL Server's total top max memory setting in the SQL Server configuration settings. So we basically take 2 gigabytes off the top. That way, analysis services would run well without any contention from SQL Server. The only problem is some of the dev teams who might have a database on that server would say, oh my gosh, who changed this max memory setting? Let me give SQL Server the full maximum amount of memory. And that's a big no-no. I don't want that to happen. I have specifically configured that value. And so by setting this, first calculating this value and then setting the system to check for me every day on a day-by-day basis, I could tell if anyone had ever tinkered with it and go back to the dev team leads and say, hey, have you been on, server London 01? They're like, no, why do you ask? And so you could then get to the root cause of that problem there. Okay. Now, another thing I would use, again, this is an alternative to the X events, because you can do this in X events now. And so another thing I would do is I would actually use a feature called DDL triggers to monitor any changes at all in the objects that are in a production database. And so, like I said, I had a difficult time in which I had developers who had SA passwords to production servers or dev servers, and they weren't supposed to make any changes except on the production servers, except during specific rollback time or product rollout times. And sometimes they wouldn't honor that. So what I discovered is that we have these DDL triggers, which DDL is a subset of the SQL superset of commands, and DDL encompasses create, alter, and drop statements. So create stored procedure, alter view, drop table, any of those kind of objects. So what you would need to do is create a place somewhere in your SQL Server in which you are going to keep this table of history of DDL changes. And again, X events can do this too. So let's say I've got a table called DDL events, and in my case, I'm just going to put it in DBO in the MSDB database. So I've already got that table in there. Then I make sure that I grant the right permissions, because the process, the DDL triggers process, is going to be inserting records into that DDL events table. Okay. Then when we go to our specific database, let's say, I don't know, CorpDB, So let me change it here. And then what I would need to do is create a DDL trigger. And you could set it on the database level, you can set it on the server level, and you can also set it for all the DDL events. And there's lots of other events you can set it for. For example, logins and logouts. You can set it on, all kinds of different things. So we create this trigger here. And what it says is, let's declare the proper variables. Going to make sure that the ID is tracked so we know what person or client is doing this work. And then we insert into the table, we kind of shred some of the event data and plug it into these columns here. All right. So execute that. That's in the Corp DB database. Now, if you ever need to roll out software, what I recommend is that you don't drop the triggers. Instead, what you do is you disable the triggers, basically just turning them off as you make changes to the objects in the database, turn them back on with the enable statement afterwards. You can drop them, of course, if you want to, but you'll have to recreate them again if you're going to continue to use this as as a means of keeping track of anyone making changes to your system. So, all right, let's do a test here. And I'm going to call, instead of cork table, I am going to call this, let's call it KC. And I'm going to go up a little bit as well. Instead of saying my table here, I'm going to say KC. Okay. So I'm going to create it, I'm going to alter it, and then I'm going to drop it. Oop. I must have created my trigger wrong. So let me drop that trigger. Insert DDL events. Sorry. So I created the trigger. Insert DDL events. Select. So where's my insert going to? In fact, let me just go to the MSDB database and do this there. I believe that I have the trigger already created.
It's looking like it's saying that it doesn't have the table DDL event.
Right.
So where do you create that?
That's up here. Oh, so did I not create that? Let's try it one more time. Okay, already that table. Then grant. And then let's see, I'll try it one more time. Go to Corp DB. I believe that trigger is already there.
Did you have to declare insert into MSDB.dbo?
Probably. I think I did that while I was in the database though. So I'm in MSDB.
No. I mean on your, when you're in Corp DB under your trigger, you're creating the trigger there.
Yeah, that's what I was looking at actually when I was looking at this statement here. Yeah. Declare insert.
Right there.
Yeah.
MSDB.
There we go. Let's see what happens.
There, that looks happier.
I've done this session a dozen times and I've never had this problem. I bet I must have like fat fingered it at some point and screwed things up. Oh, you know what? Again, now Corp DB, execute. Okay. Now let's try this one more time. Okay, so did all of that. Now let's go back over. Well, you know what? I'll just change it here. We should be able to see it. MSDB dot, like so. And then what we should see here, there we go. 2020 down here. So here's the create table, KC table. Here's the alter table. Here's the drop table. And if we scroll over to the right, we can see who the host name is, what program they're using. We can see what the login name of that person is. And so basically I could go, you know, and raise some hell with the dev team that was doing stuff they weren't supposed to do, if that makes any sense. So the idea here would be, you know, people would say, oh, you know what, let's change this index and we'll add a couple include columns in it. And it turns out that that include column has, you know, makes the index much bigger, and it causes tons of fragmentation, and now things get really slow because it's going to have to recache all the tables that were normally involved with queries that reference that index. And so there's a cascading chain of events that the development team hasn't thought of in terms of what happens when they change an object. And so this is a way for me to keep track of that and see who's changing things, so that you can answer that kind of age-old question of who changed something. You know, it's great yesterday, something may have happened. Okay, so that's the first thing that we want to try. Now the next thing in our methodology is this problem inside or outside of SQL Server? And this is consequential. Many times I, in the old days, and others that I've talked to, have started to do, you know, they started with that knee-jerk response. Oh, the dev team must have done something again. What are all the new stored procedures they've written since the last time we had a problem like this? And they dive right into SQL Server and they start trying to fix problems. And many times over the years, I've encountered situations in which that was the course of action that the DBA took, but, or maybe it was the lead dev on the team, but if they had only taken the time to go and look in the Windows logs, right? And they've gone and looked in, there's a system log and the application log. Typically, you're going to want to look in the application log. And once they did that, they're like, holy smokes, there's a DNS server problem. I've been trying to fix a SQL Server problem that doesn't exist. The reason everything's slow and timing out is because the DNS server isn't working right. And so it's, you know, they're timing out because of that. So it's the kind of thing that's very fast, very easy to check, and you go quite quickly. You can rule in or out whether anything was going wrong with the SQL Server. There are two other things I check here as well related to this. One is that the SQL Server agent has its own separate log. So I do check that as well, particularly if it happens overnight when we have lots of jobs running. And then there's one other thing I check. Every SQL Server that we have has a folder where it will dump memory dumps, either a stack dump, either a mini dump or a full dump. And there's not really an alarm that tells you that that has happened. So that's one of the things you can actually use with the WMI events in the SQL agent monitoring, SQL agent alerting, is you could say, tell me if there are any files in this folder. So normally what I would do is look in that folder, which is defined in your SQL Server settings, look in there, and if there's a stack dump, then I take it out of that folder, put it in a temporary holding place, and use it to troubleshoot the problem. So I also will go and create a alert on that folder if any new files show up, because SQL Server doesn't tell you when it has a memory dump unless it tells you the most direct way it can, which is to crash, right? So you want to check that as well. There's also a couple slides in here, which I hid for the purposes of this presentation, that also step you through the process of creating those severity level 18 and greater alerts. However, let me go ahead and pop over here and show you in Management Studio. I also have a script here for you, originally written by Tim Radney, and it has it's a script that will create all of those severity level, in this case, 19 and above errors, as well as for some specific kind of important error numbers that you need to keep your eye out for. I'm actually about to finish writing and publishing a blog post that goes into a specific whole set of individual error numbers you should keep an eye on. For example, some of the important deadlocking errors happen at severity level 17. And I'd never recommend that you watch all of severity level 17 because it's really noisy. And 99% of the noise coming out of there is not the least bit important. But there are a couple deadlocking messages that come out of there that you might want to watch. So I'm writing another version of this that has probably a couple dozen different error numbered events that you want to keep your eye on. Okay, so there is some stuff in here that'll make your life a little bit easier. Okay, so check the error logs. That will tell you whether it's inside of or outside of SQL Server. And if it's inside of SQL Server, that's actually not the worst case, right? So if it is a stack dump, if you find SQL agent error in that log, if you find a SQL Server error in its log, that's not terrible. Why is it not terrible? Because you actually may have found a resolution to your problem. If you don't find any error messages, what that means is you're going to have to do a lot more research. It might take 20 more minutes to identify the problem, or it might take 2 more days. Okay, so I think you can kind of get an idea of the gravity of what I'm talking about. If we find errors, let's fix those and resolve that. Then there's a really good chance that our problem will go away. One thing that is kind of funny, particularly the further back you go with older versions of SQL Server, there was a time when most of the error messages, the entirety of their documentation was the error message. That was it, full stop. And if you went, and looked at Microsoft documents, nothing in there about it. Like the first time I ever encountered a resource semaphore error, I didn't really I didn't really know what a semaphore was. So I actually pulled a dictionary off of the shelf and I looked up the word semaphore, and it said something along the lines of a flag and signaling system used on train tracks and for nautical shipping maneuvers. And I'm like, whoa, this does not help at all. But as it turned out, when I called Microsoft and talked to a person on the support team, what it turned out is it's a memory issue. A resource semaphore is typically a memory issue. And what they had done is they'd taken the naval, when they held the flags in different positions like that, that says go forward or stop, move that way. That's what a semaphore is. And so inside of Windows, the dev team said, we're going to use the term semaphore to mean when we have to put a lock on a specific thing in memory, kind of sub latch level, we're going to hold it temporarily in the thread pool. And so it's like, oh, okay. So, there was just no documentation on any of that. Nowadays, most every error message, if it actually causes problems, will have some documentation for you. So the good news might be that it's a problem found and it's easy to fix. In some cases, it's a problem found and it's hard to fix, or it means you have to restore SQL Server to its last good version. But in many cases, unless you have a massive database and really, really difficult time restoring things, that will be easier than having to go through the full spectrum of different options to look at to do a full root cause analysis for troubleshooting. Now, you're going to need to do more research under a couple of different circumstances. One is, of course, if there's no error found, then you need to continue to look to see what else might, look at other sources of telemetry to see what else can kind of cue you in. And then the second thing that you might encounter is that you do find errors, but they don't relate at all to what you're experiencing, and that the errors themselves are not happening at the time that the problems are happening. For example, maybe you get to a replication retry errors at night, and the problem you're experiencing is some kind of slowdown in your system during the day when the end users are in there. So now we have to go to the next phase. And in each of these phases, as we move along, Think of it as a set of sieves where we've got a bunch of dirt and soil in there, and we shake it, and everything falls through except really big rocks. And then that you take the next more finely sifted soil and you shake that again, and then you find still large rocks, but not big ones. So these two, what has changed? Is it inside a SQL Server or not? Is it caused by an error in SQL Server? Those are the kind of the big rocks of different sizes. Now what we're going to do, oh, I even had a slide for the sieves, right? So now what we need to do is start to zero in on the problem. And in this case, the way you start to do that is with weight statistics, okay? Now, weight statistics are a great place to, really get moving on your root cause analysis. There are, however, some products built there that are sold as monitoring products, and they're based entirely on weight stats. The problem is that weight stats are a good place to start, but you must not stop there. There is much more to do beyond looking at the SQL queries that have the most weight statistics, okay? I'll explain that a little bit further in a moment. But here's how weight statistics work. What they do is anytime SQL Server has a thread, has a SPID that has to wait on something, it has a weight statistic for which it categorizes what they are waiting on. And that reveals the general category of resource problems that you're having on your SQL Server. When it was introduced in SQL Server 2005, there was a few hundred wait types. In 2008, they added something called a preemptive wait type that doubled the number of weight statistics. And with each new release of SQL Server, they've added more and more weight statistics. And I'm going to show you the top 10 or top dozen that you need to focus on. Here's how weight stats work, though. I'm going to use an analogy, all right? When you connect to SQL Server, you are assigned a SPID by a process called the SQL OS, SQL operating system. And that's kind of like you're in your car and you're going to go to a fast food place, and some of them have multiple drive-through parts where you can request what your food is. So think of that as like you being in line on a scheduler, on a thread, on a SPID, and you're asking SQL Server to give you something, like to answer your query or to create a table. And so you pull up in line when it's your turn, and hopefully you get exactly what you asked for, and it's very fast and it's completely right. Now, in my case, I have one son and 6 daughters. And so there were plenty of times when we would go through our line and place an order, and they would say, please pull forward and wait because we don't have enough French fries for y'all, And so we have these situations where we're waiting on a thread, and either we do something wrong that makes that process super, super slow, or there aren't enough resources that partition, inside a SQL Server to answer that request fully. So that's the analogy. What actually happens behind the scenes is SQL Server has these different SPIDs. If you ever look at SP who is active or SP who, you'll see all these SPIDs that say they're running, and then you'll see other SPIDs that are sleeping. Usually those are going to be some of the process SPIDs that keep SQL Server alive and functioning normally. All of the SQL Server internal process SPIDs are going to be number 52 or lower. So only user SPIDs, or maybe like a SQL agent job or something like that, will have a SPID over the low 50s. So you connect and you say, select star from my table, okay? At the same time, there's lots of other people out there who have done a lot of work or are in the process of doing work. And so they are waiting to get access to resources on the SQL Server. Typically, they have been given, let's say, the locks they need. They've been given access to the table. Now, all they need is some time on the CPU in order to actually complete their work. And their status, you will see, will say runnable. And that could be way backed up depending on how busy your system is. You'll see that there's only as many running tasks at any given time, running SPIDs at any given time, as there are cores on your SQL Server. And maybe even less because you've used max degrees of parallelism or CPU affinity or something like that to otherwise limit the number that are active at one time. So let's say you've made your request, select star from my table. So in the analogy here, you said, hey, I want 9 Diet Cokes, you know, the Route 44, 9 of those. And they're like, we've got to change the soda. You know, they have these connections that they make to the CO2 and the syrup. So we got to change the syrup over. It's going to be a few minutes. Please wait. So what SQL Server says to that SPID is, just like the fast food place said to me, they say, step out of the way, please. Go to the waiting queue, or also known as the suspended queue. And someone who's in the runnable queue gets to step up now onto one of those CPUs, one of the cores, and get their work done. Let me go back one. If you are in the suspended queue, you begin to accumulate resource weight statistics. And so there's a variety of resource weight statistics that tell us you don't have what you need to get your work done. So maybe it's taking a long time for SQL Server to load some archive data that's on this one tier of your SAN that's these really low-end 7,500 RPM drives, but you got 20 terabytes of those kind of drives. So it's taking a long time. It's going to load up those the archive data requests that you've made. And so there's a weight statistic for that. That's called a resource weight. Or maybe you need memory, or maybe you need locks. Those are all resource weights. On the other hand, if you're in the runnable queue and all you need is a bit of CPU to get your work done, that's said to be, in broad terms, a signal weight. Kind of like when kids are on the sidelines at a sport, they're like, coach, put me in, I'm ready to play. I'm giving you the signal. I want to get in there. So if you look at a SQL Server and you see that the signal weights are really high, you know in an instant that you actually could benefit from more CPU. All right. So how do we look at this data? How do we look at the weight statistics data? There's 2 ways. We've got 2 tables. One is to look at DMOS weighting tasks. And this is used far less often, but it does have its uses. What this does is this tell you what all of the SPIDs that are running right now, this is all of the different weight statistics that they are accruing at the moment. It's really accurate, but it's also only true for this point in time. So if you check 5 minutes from now, SPID 73 might be gone. So it gives you information like this, right? And we see some, we see some service broker things happening here. We see the lazy writer sleep tasks and so forth. The other kind is what we would find from using the DMOS weight statistics table, DMV, and I'm going to show you that in a demo in just a moment. So there's a slide here that has the top 10 weight stats from the field, but let me go to a demo and show you a little bit more here. So I have a set of queries here that actually take us through the process of using dynamic management views and so forth to get to the root cause of a set of IO problems, okay? So select from DMOS weighting tasks, just like what we saw a moment ago. That tells us all the different SPIDs that are active on our SQL Server. And as I mentioned, anything under 50 is going to be kind of system processes for SQL Server. Anything over 50, if we were to look at DMOS weighting tasks, would be users or something created by human beings, like a job or PowerShell scripts or something doing work. Now, to get into the specifics of the different weight stats accumulating are the table DMOS weight stats. However, all of these events that you see down here, we don't really need to pay any attention to those. There's a large number of weight statistics in SQL Server that are merely keeping track of the normal organic processes that keep SQL Server alive, kind of like our pulse and our blood pressure and our heart rate. And so I've got a copy of my buddy Paul Randall has a script here. And what it does is you see where the weight type is not in. So you can see right here, weight type is not in, and it eliminates a whole bunch of these weight statistics that are probably never going to come into play for your SQL Server. Now, the problem is I haven't been running much workload, so there probably won't be a very large amount of weight statistics accumulated on my SQL Server, but let's go ahead and run it and see what we get. Okay, and this actually makes sense because I have changed my default trace to collect additional information. And so we can see that it is accumulating enough to cross that threshold here. In fact, let's go ahead and do this. Let's just grab all the weight statistics since my server has most recently been started. So keep that in mind. Weight statistics aggregate since the last restart of your SQL Server, okay? So here we see that I do have a weight statistic for XTP preemptive task. And remember when I was talking about how you had signal weights and resource weights? That's what this is telling us here, okay? We have weights that are signal weights and weights that are resources weights. And this tells us that in general, for this weight statistic, well, they're neck and neck right here. And the total amount of signal weights is 296, very low. So actually what this means is I don't ever have to worry about CPU for the workload on this SQL Server. It is handling it fine, okay? So what are those top 10 weight stats that you need to pay attention to? First of all, for CPU pressure, you're gonna see SOS scheduler yield. What the SOS scheduler yield weight stat means is that there are so many SPIDs trying to get access to the CPUs of the SQL Server that it's not able to get a lot done at any given time. So SPID, let's say Daniel steps up, he has written his query, and it doesn't really even let him finish before it says, you know what, Daniel, you have to yield your time on the SQL CPUs, and I'm going to let Fred step up and get a little work done on his. Oh, Fred, sorry, there's so many people waiting. You got a little bit of work done, but now you have to yield so the next person can get some work done. So that's what SOS scheduler yield means. CX packet weights, on the other hand, simply means that SQL Server has parallelized the work that it's doing. And it's not uncommon to see that as one of the very highest weight stats. But is that actually a problem? The answer is, at least since probably SQL Server 2012, it is rarely, if ever, a problem. It is more likely that it is a symptom that something might be wrong, but it's not a problem in and of itself, okay? Then we have locking weights. And anytime you see something that says LCK underscore, that means that we have important weights that might be causing blocking. One common type of weight stat you'll see is LCK underscore SH, but it's not always a bad one because that means lock underscore shared. If we see LCK X, that means exclusive lock. So somebody is trying to lock records that they want to insert, update, delete, merge, make changes there. And so that's an important one because it's blocking other people from doing work. Same with M underscore U, that means mutex update, and M underscore X means mutex exclusive. And then we have memory weights. And these are surprising to a lot of people because they didn't realize there were weight statistics that would tell you pretty much what part of the cache SQL Server is waiting on. So if we see page latch underscore X or underscore SH, that means we're waiting on activities related to the data cache to finish. Typically that means maybe something is being loaded or maybe something is being evicted from the data cache. In the same way, if we see latch underscore weights, then that means we have the plan cache side of the cache, and we're waiting on that. Usually, it could be, there's actually a lot of additional small caches inside a SQL Server's buffer pool. So there's things like sort caches and hash buckets, and every X event has a cache that you define, log buffers. So there's lots of other ones out there, and it could be any of those as well. If you're running on SQL Server 2012 and earlier, that memory management system was updated afterwards. And so we do see more non-data cache weight statistics appearing on pre-2012 SQL servers. So keep that in mind. It was not as good of a memory handling system on earlier versions of SQL Server there. And then if we see resource semaphores, remember I told you about that? Flags, you know, come forward, back, and all that. That if you see those as a weight statistic, that means the SQL query memory grants are either too much or too little. And so that is a good indicator too for you to follow up. I/O, of course, particularly in the days of hard disks, we would see tons of this, but we still see a lot of it today. Page I/O latch for share, you know, page I/O latch _sh or _ex for exclusive. So that means for reads, that means select statements, or writes. So that means the other insert, update, delete statements. Lot of problems with transaction logs being fast enough. So you might see write log or log buffer waits. And then we have general IOPS that sometimes are slow, such as async IO completion and IO completion. And then finally, you always got to keep in mind that network can be a problem, particularly the bigger and more significant the workload on your SQL servers are. I've even seen servers that were, you know, so busy that they had to have they had to have 2 or 3 or 8 NICs in that server to support the load. In my case, the most I've ever worked with on my systems was 2 NICs on our big production systems, because they were busy around the clock. And when we were running a backup, we would have to run the backup on the second NIC so that it wouldn't interfere with the end user traffic on that SQL server. So you can definitely see network throughput pressure there. By the way, if you or your corporations use any Microsoft Access as a front end to your SQL servers, for some reason, Access is well known for causing network pressure on your SQL server. All right, so if we take a look at the, our step-by-step methodology here, let me see if I can find it. Look here. We want to take a look at the weight stats and see if any of those are the problematic ones that I pointed out, and they're way up at the top, right? They're far and away bigger than the other weight stats. But once we've done that, it doesn't necessarily point out the smoking gun. You know, what's that root cause? So what we want to do here is we want to correlate additional telemetry, additional metrics against that weight stat that we've seen, so that we can be sure that we are zeroing in on the right SQL statements or things like that. So what we need to do here is collect additional performance information. And there's a couple ways that we do this. First of all, we do need to collect some perfmon information. At least I'm a big proponent of that for things. So for example, if we see those memory related weight statistics happening, there are more granular perfmon counters that can tell us very, very detailed information about it, about those memory problems that we've already seen kind of in the big picture. Then we need to extract event level data using X events or using SQL Profiler or something called a server-side trace, which is basically just a scripted version of SQL Profiler. So Daniel has talked about X events. I'm going to take you down the other path here. So using perfmon is something that you all have probably done at some point or another as a DBA. It's a really simple interface where you pick and choose the different counters, perfmon counters that you want to watch, such as memory, disk I/O, SQL Server locking and blocking, and stuff like that. There are some best practices around that, where you want to run perfmon from a server that is not the SQL server you're monitoring, right? And so in this case, I'm looking at latches and locks. I'm looking at some SQL statistics, such as batch requests per second, and lock timeouts, page life expectancy, and so forth. If you're doing a really intensive rather than a casual kind of troubleshooting, what you want to do is you actually also want to go up there to the file menu and save this log as it's producing data. I've got some a list of counters for you here in the slide deck to keep track of, and some recommended values for what they should be in general, right? Kind of rules of thumb. So for example, if you have SQL Server Memory Manager and your memory grants pending should be 0. In fact, this is the single most effective means of telling if you have memory pressure on your SQL Server. The bigger this number is, the more threads you have or processes you have on this SQL Server that are waiting to get some access to memory, okay? So that's the kind of stuff I have in here. Things like forwarded records per second and page splits per second. So you need to define all of that stuff. And if you're lazy or you're being casual, there's a little bit of a shortcut I'll show you here as well. There is stored procedure in the toolkit for this session. And I used to write these really popular posters that gave you a whole list of probably the 75 most important perfmon counters for SQL Server troubleshooting. And my buddy Brent contributed to that, Bob Ward and some others contributed to that poster. Well, a new friend of mine I met a few years back, Patrick Keisler, turned this into a stored procedure as well. And what you can do here is there are a couple tables inside, DMVs inside a SQL Server that expose the perfmon counters, DMOS performance counters. Now, this particular set of perfmon counter here, it only retrieves SQL Server perfmon counters. So if you need the Windows perfmon counters, sorry, it doesn't capture those. But in this case, what this does is that, let me make sure I scroll to the end, that it gives us output. Yeah, okay. So let me go ahead and execute this. And so what this does is it takes a look at all of the activity on your SQL Server for these different perfmon counters, collects it into a temp table for you, and then it displays those perfmon counters at the end. So, oh, I'm not sure. I think I just created the stored procedure and didn't actually run it. Let's see. I go up to the top here. Yeah, so let's see. Now I could execute this. In fact, let me go ahead and do that. Not supposed to type, but I'm going to go ahead and I'll do this at the end here. Let's see if it actually produces an output here. Nope. All right. Got to execute the stored procedure here. There we go. And so this is the entire list of perfmon counters that I have been evangelizing for years, 2 decades actually. I first started to write about this in 2000, the year 2000. And so you can see that there's all kinds of stuff happening here. I don't know if I have any memory grants pending. Nope, 0. Okay. So if you don't want to write your own, you at least have this now to kind of give you an idea of what's going on in your SQL Server system. And if you wanted to, you could turn this into a permanent table and keep track of this over time and have SQL Agent Job pull these values in, you know, on a regular basis. And so you could track trends, okay? So we need to collect these perfmon counters to tell us, for example, yes, you really honestly have memory grants pending. So that general weight stat that says that you have high weight stats for signal weights, or you have high page latch weights, we find correlating evidence that this is truly the case. The next thing you want to do to get down to the specific SQL queries that are causing your problems is you want to use one of the event management systems to find out what are the different SQL statements that are firing at the time that cause this workload. So again, Daniel showed you X events. I'm going to show you just kind of briefly Profiler. Now, Profiler is a GUI, and the problem with Profiler is that if you use the GUI, it's pretty high overhead. It's about 7%. And for each person who uses the Profiler GUI, it's about 7% overhead. So if I use it, and then Dan uses it, and then Curtis uses it, then we got a problem, because now we put 21% overhead on the SQL Server. There is a different means, though, in which you use server-side traces. And so server-side traces are stored procedures that keep track of the exact same stuff as what you're tracking in Profiler, okay? Except it doesn't use the GUI, and so it kind of completely skirts around that big source of overhead. Another advantage to server-side traces, and actually to X events, is that you can set stored procedures to be auto-start stored procedures. And so all of these server-side traces are invoked through stored procedures. So that means you can make sure that anytime your SQL Server restarts, you've got logging already, okay? So here's the superpower of why I continue to teach Profiler and server-side traces compared to X events, okay? What we have here is you're going to invoke Profiler, and you're going to choose your template. Standard is okay for a demo, but you'll probably want to add a few of your own things. And it looks kind of like this. We've got a trace name here. We tell what server we want to connect to, what version of SQL Server it is. And again, just like in in Perfmon, you want to save it to a file. This is how you get access to the superpower. You choose the events that you want to track from the events tab. Like maybe you don't care about who's logging in and out, so you turn those off. But you do want to add, I don't know, maybe you want to add something else in here. Maybe your server has, I don't know, CLR, let's say. So you add a couple events for CLR. If you do that, make sure that you always always check the start time and the end time indicators here on the trace events that you're looking for. And then also there's a column filter here. So for example, you might know that you only want to do this troubleshooting on one database, one user database. So you can go into the column filter and say where database name equals such and such. Part of the reason that a lot of people like X events better is that with Profiler, it does the filtering after it has pulled out the telemetry, whereas X events just totally skip it if it's the telemetry, if it's not part of what you've asked for. So even though you can use these column filters, you still have a lot of overhead, right? So then when you're ready, you start run, and it begins to collect the data. And if you're using the GUI, if you're using SQL Profiler, you start to see all of these different events that you have requested it to trace to start to appear on the screen. And it tells you what the app is, and when they started it, what user event they were causing to trigger, they're triggering to fire, and so forth. Now, when you're done with your time period of doing this troubleshooting, stop the trace and also stop the Windows Perfmon trace, performance monitoring that's going on at the time. Then start a new session of Profiler, okay? And what you do is you open the Profiler trace file and load it in. Let's see if I've got an image here. So yeah, so you go to File and you say Open and you say Trace Data. Then you come, show all the trace that you just collected. Then you go back to click on File, and you see there's an option there that is ghosted out most of the time. That's because most of us use it for live tracing. But when you load a saved data, you see a new option that's not ghosted out, import performance data. You click that button, and what that does is it allows you to load in the data you saved from that perfmon trace. And then what it shows you is an overlay of all the perfmon data you were collecting at the same time as all of the SQL events that were firing. So you could look here down on the part of the graph that shows all of these different perfmon counters are starting to peak. And you could click right here to see what that activity was, and it would take you up above to the exact SQL statement that fired off right there. And so maybe that SQL statement is something like insert into this and such table, select from another table, right? So it's a big, heavy logged operation. Conversely, you could come up here to the top and you could start scrolling down and look and see a particular SQL statement has a really high CPU and it has a really long run duration. And you could click on that and it will jump this red bar to the exact spot where where that query was running on the performance graph. And so suddenly you have this really nice correlation between the individual statements as they're firing and the exact resource consumption as it is happening. Any questions on that before I continue?
I'm still working on a way to get it to work with extended events, man.
Yeah.
I'm gonna make it happen.
Well, the good news is that I and a whole bunch of MVPs keep asking the Microsoft dev team for this, and they have said that it's on the roadmap somewhere. And as soon as that happens, we're gonna, I'm gonna stop evangelizing Trace in any way. But until then, this is still a great technique. Okay.
Yep, I agree.
Now, another thing you can do, and in certain cases, you can skip the perfmon and profiler work because dynamic management views are fantastic. And so what you can do here is you can actually just query specific DMVs to get to the SQL statement you need. And so just as an aside, a lot of people don't know this, but you can actually restart any of these DMVs without restarting SQL Server. What you can do is you can say dbcc SQL perf, and whatever the DMV is, like OS weight statistics or OS performance counters, you can say, put that name there in quotes and say clear, and that will start them over again. Otherwise, DMVs have the problem of they always refresh completely when you restart SQL Server, and they're always aggregates since SQL Server was last started. So yeah, keep it in mind. So again, we have these great collections of DMVs. We don't necessarily have to write these queries ourselves to the DMVs because Dr. DMV, Glenn Berry, has given us this great collection of different DMV statements that we can use. So let me show you a couple of those. All right, let's see here. Yeah, I'll say go ahead. Save that. Oh, by the way, when you go into Profiler, you can define a Profiler trace that you want, and then you can say export from Profiler. And what it will do is it will create the full declaration of that Profiler trace in stored procedure format. That's what a server-side trace is just the stored procedures. And so this gets, if you use the server-side traces, this gets rid of all of the, not all, but the majority of the overhead generated by Profiler. And so that's what this kind of stuff looks like here when you create those, okay? So here are some different DMVs that you could use. For example, if you know you have IO problems, you might first want to see which of your SQL Server databases is causing the most IO. And then you could drill down into it deeper and deeper. Like once we discover that it's this TPCC database, then we want to go into that specific database and or maybe we want to get more information about that particular database's IO. And so we can use different DMVs for that. So DM IO virtual file stats, when we execute this one, it actually tells us the number of reads and writes. And you can get this broken out even further. Like, is it update statements that's causing the problem, or is it inserts and deletes? The most important IO counter is typically latency, meaning how long do you have to wait? And so here's an example of a query that will tell you that information. Again, it's using DM IO virtual file stats here. And so TPCC is my busiest database. And here I have my database ID and my transaction logs. So I have all my transaction logs here. And I can see what their latencies are for read operations and write operations. I can see how many IO stalls they have. A stall is when it attempts to write or read, and it is blocked, and so it kind of stalls, like if you're trying to merge on the interstate or something like that. It didn't make it, so let me back off of that. All right. So now, one of the things that you can do a lot of the time is you can actually just go to the statement level. And so we can use queries like DM exec query stats, and we can join that to DM exec SQL text to find out what SQL statements are causing the most issues. So if you've taken a look at your DMOS weighting stats for your weight statistics, and you find out this IO problem, then we could come in and take a look and see what SQL statements are causing IO problem in these different databases. And I believe I have one more. Yeah, this is my favorite script. If I'm going to skip ahead to just look at SQL statements by weight, and this is written by Jimmy May. And I believe Jimmy's retired now. But what this does is it's also got at the end, at the order by, you just uncomment out the specific order by statement that you want to use to organize your top 25 most offensive SQL statements. So if you have duration issues, then you might uncomment out QS total elapsed time. If you have physical read problems, then average physical reads. So go ahead and execute this. And I'm going to see what my top 25 SQL queries are for this SQL server since it was last rebooted. And I'm pretty sure, since this is largely a quiescent SQL server, that most of these are going to be very simplistic queries. Okay, so we have one user database here, one user database query happening in the top 10. And we can see what the different resource consumption is for each of these. So maybe that's how we want to work on it, based on the number of resources that are consumed, but that's not always the case. A lot of times I like to do that wide at the top and narrowed down to the most detailed and granular way of finding that root cause problem, because if you don't do it that way, if you jump right to the end here, often what you'll find is that you're responding to that knee-jerk wait sort of situation. Okay. Oh, no, I'll go back to the slides here. Okay, so actually we've hit the end of the presentation here. Just to wrap up, don't forget, has anything changed? That's the first thing to look for. Once you rule that nothing has changed, then you start to see, is it inside of SQL Server or outside of SQL Server? And typically, very quickly and easily identifiable by just pulling up the Windows application event log to see what has happened there. Then you check to see if it's caused by SQL Server or SQL agent error. Usually I look at each of those two logs, as well as check the folder, the default folder that SQL Server uses to put a stack dump in there. Next, I look at, once I've figured out that it's not caused by an error, I've eliminated that, then I take a look at weight statistics to tell me what the general area of the problems are on this SQL Server. And then finally, I correlate those weight statistics against additional specific session information and more granular information from Perfmon and either Profiler or X events. And that gets you right down to the root cause of your SQL Server statement that is causing the problem on your SQL Server. Then you have to go back into Management Studio or Azure Data Studio and fix that, fix the query that's causing all the problems. So let me ask at this point, what kind of questions do we have now going into the final few minutes here? Anyone put some questions in there?
No, I don't have any in the chat at this point. I guess the biggest one that I personally run into is I don't find, what would we recommend as a good resource for or maybe sessions on using Perfmon? Because I usually know it's like, okay, well, I need to check on something, but for me, I use extended events. I'm using, weight stats. I'm using, query store, trying to figure out maybe some of the stuff. And I've kind of drifted away from Perfmon, and I kind of forgotten a bit of it.
Right.
So that's where I'm at.
Okay. So I don't have it put here, but I'll bring it up to the screen. I do have some, I have some blog posts on this, and one of the white papers that we have at my blog is just about how to do this whole process that I walked you through, and it spends a lot more time on weight statistics. So I'm not sure if this is easy to see, but it's century1.com/blog/Kevin Kline.
Mm-hmm.
And so there's a multi-part troubleshooting series there.
Mm-hmm.
And it goes into a pretty good deal of detail about using Perfmon.
Got it. Thank you.
Yeah, and so there's even an aggregation of all of that has all the slides, all the scripts, all of the articles, and a link to an older version of this presentation. So you can download. So here's where you can get all the scripts right here. Here's where you can get the slides.
Very nice. Appreciate it.
Yeah, end-to-end troubleshooting checklist for Microsoft SQL Server.
So I have a question.
Yes.
We recently upgraded a monster database from 2008 R2 to 2016.
Mm-hmm.
And I did the query store, and I left it in 2008 compatibility mode, and then upgraded it. And we had a problem with one particular function, a scalar function, that was running long, and I couldn't see it using the query store. What's the best way, or in your experience, what's the best way to be able to identify that? I had a really hard time using Profiler, trying to find why this particular stored procedure function.
Okay.
Well, the source was a function, but I'm sorry, it was a stored procedure call. And I wasn't seeing it using Query Store. I wasn't seeing it with Profiler. Right. I wasn't seeing it anywhere.
Yeah, that's a great question. Dan, did you
Yeah,
sound like you wanted to respond?
One of the things that I've used is if I know that I'm having an issue on a specific procedure, specific object, there's a really good, I have a good demo out there on my GitHub that allows you to take any module, either being a function, a trigger, or a stored procedure, and it'll actually trace it, and it can get you information such as like how did it get called, and it can also get you more information of like what were the parameters that were passed into it to make that call, and then starting to take some of that and say, well, what's the execution plan now of that, and then starting to dig into it. If you're running a scalar function, I mean, sometimes it can be a little tricky, but you could try, if it's not touching too much schema and you're depending on your change management, you could schema bind it. That could be an option, but there's
not an option. This database is a nightmare.
Yeah, there's a lot of trade-offs on that.
Are you able to do any kind of tinkering with the code at all?
I have since recoded we've had problems in the past with these scalar functions, and I have
Yes, they are
since
problematic for everyone.
recoded them to make them table valued functions and recoded the store procedure that we were having trouble with, and that's in QA right now. So it was just it was just so hard to see it. I didn't know if there's
Yes.
anything in extended events or anywhere else that I could have maybe found this function quicker.
Mhm. Well, I will say that this is something that Plan Explorer is really good at finding. So if you had like a
I have
general,
Plan Explorer. I love it.
Woohoo! Oh, thank you. Yeah, and we just released a new version maybe a couple weeks ago. So if you haven't updated lately, we have a new version out.
Okay.
So yeah, it would have at least made it easy for you to see that that function call was problematic, that it was, you know, sucking
Okay.
up a lot of resources. The a couple thoughts come to my mind as well in terms of query tuning for that that specific function that was a problem for you would be to try it with and without the newest. You can actually change like compatibility level and the cardinality estimator at a, you know, at a statement level if you want to do that, or an object level. So you might try to see if the changing it so that it'll use the new cardinality estimator would cause it to perform better. There's also a couple bloggers that if you're going to rely on Query Store, that I would seriously encourage you to pay attention to. Erin Stellato,
Yep.
you know Erin?
Yes.
Or her stuff? Yeah, Erin's fantastic. She does look at SQL Help occasionally. And she does answer emails too. It's ERIN, not AARON. And she's, in my opinion, she's the goddess of Query Store. And she has lots of great blogs. She has videos on Pluralsight. So she has probably addressed the specific problem that you're interested in. Also, her colleague, Jonathan Cahias, who I referenced in this session as well, he's amazing at it too. But he doesn't blog about it quite as he does blog about it, but not quite as often as Erin does. So those are my two go-to people for these kind of questions. Now, having said that, there was also a great article written by Kendra Little, and Kendra's over at Redgate, and I'm just crazy about her. She not only does she do amazing writing, but she also is really funny and has these little cartoons she does and stuff. And so she had a recent, well, maybe a year old, so not brand new, but she had a blog post recently about Query Store that might have come into play too, about how to see a lot about what Query Store is doing. And then there's this concept, it's not the official term, I'm sure there's a different term, but when you specify for SQL Server to use a plan guide that you've set out, you know, Query Store sees that, oh, this is a plan you've already tagged as a bad plan. She goes into a pretty good detail in that about what they call a morally equivalent plan guide, if you've ever heard that term.
No.
So what that means is, let's say, for example, between the first version of that query that's in the store, Query Store, and now when it encounters a regression that you want it to use a plan guide for, someone has dropped an index between then and now. What SQL Server will do is it will take that into account and build the closest execution plan it can to the one that was referenced earlier. So it's not equal, but it's morally equivalent, right? That sort of idea.
Is that all versions since Query Store was introduced?
I'm sorry?
Was that introduced when Query Store was introduced?
I don't think so. I think that's a 2016, because Query Store came in 2014. So I think this is a 2016 extension.
No, I think Query Store thought that was 2016.
Thought it was 2016.
Oh, okay.
Yeah.
Then consider me wrong there.
There was one change also in the Query Store retention that happened. I think it was in 2017 and or 2019. The Query Store capture mode, I believe was in 2016 set to auto, and auto was actually to capture queries based on a resource consumption. And I believe certain trivial plans would not be captured.
Yeah,
And
that's.
so
Mhm.
it may have been that the scalar function consisted of what would be considered a trivial plan, even though maybe the iterations or the way it was called were actually causing a performance. So you can change that in later versions of Query Store by switching it to the value of all, and it will capture all queries.
Okay.
But that can cause a performance issue because, you know, it's a trivialization, and it may say, hey, we're going to be holding up a lot more data. So you kind of have to weigh that. You know, it might be something, yeah, we're going to capture everything in QA and dev, while we'll leave it on auto in prod. And if something does come up, then we can make that change and then switch it back when we've done it. So do be aware of those options later.
Okay.
Yeah. Good question,
Hey,
though. Appreciate
on
it.
a side note, Dan, I would love to have a little extra thing, extended events for Query Store.
I'm working on some to find you know, the delays of Query Store. There's a couple extended events and wait stats that I've used because I talk on, you know, everybody's like, well, what's it going to cost me to get Query Store? There's a specific wait type. I think it's like QBS load data, that somewhere in there, and that's the specific amount of time that SQL Server takes to load Query Store on a server start. And so you can actually trace those events and extended events and those wait types in SQL Server, and it will let you know, hey, it took me this long to turn on SQL or Query Store. An issue could arise. Let's say you set Query Store to 10 gigs, and you're saying, oh, it took 3 minutes to load Query Store. There are options then to say, okay, well, I'm going to enable a specific trace flag and we'll load Query Store asynchronously because I really care that my SQL Server come online before it loads the Query Store data to be available. That can also be effective when running failovers. If you run a failover, it's going to load the Query Store data before it'll actually come online. And at least in production, frankly, I'd much rather the database come online than Query Store be available.
Yeah.
So, and Aaron Stellato actually has a great blog post on those and that specific scenario. I think it's like 7752 is the trace flag for asynchronous loading of Query Store. But you can email me at any time. I'm more than happy to evangelize for Query Store, extended events, or SQL Audit. So those are my areas.
Yeah, I'm just starting with both of them. So.
Yep.
Let's give away another ebook.
All right. Well, we have had a couple people who have messaged me privately, Kevin, and said they had to drop, but they're looking forward to watching some of the rest of it. So we actually are at this point, we're down to 13.
All right.
So if you just want to roll a D20, that should be fine.
So do you, yeah, let's do that. Let's roll a D20. See what we get here. Okay.
Roll it again.
Yeah,
critical hit, but roll it again.
Exactly. Okay, one more.
One more.
There it is.
3. And so actually at that point, I have it showing as Martha.
Oh,
yay!
Yay!
There you go.
So again, Martha, if you'll just drop me an email with the name of the event, and because sometimes I don't remember, and that you won the ebook, and I will SQL in a nutshell. I'll get that out to you this week.
Okay.
Great.
All right.
Thank you.
Thank you.
You explained things really well.
My pleasure. I appreciate that. So folks, I hope you enjoyed